Yes, we have to find the properties of air. So, yeah, the molar mass will be 28.97. Constant. Universal gas constant. Yes, ideal gas constant or the thing gas constant and the number of molecules. So we can get the ideal gas constant of the air will be 0.2871 kilojoule per kilogram Kelvin. So just note down the units. So in some other cases, they may use the joule per kg to Kelvin. Also, there will be kilojoule per kg Kelvin. So there will be a joules also will be there. Also, kilojoule also will be there. So just the unit conversions. Right. So the amount of energy needed to raise the temperature of mass of a substance by 1 degree is called specific heat at constant volume. So you know what is CV and you know what is CP. That is specific.
எடுக்க மாட்டேதான் அது ஒரு மியூசிக் நான் பஸ் ஸ்டாண்ட் போயிட்டேன் வண்டி கிடைச்சி ஏறிட்டே வச்சுட்டு
Just come again. Just speaking. Making the money. You have inquiries?
No, sir.
Right. So we can continue. If you have any queries, just come again. I didn't get you, or else we can continue. Fine. I hope you don't have any queries. Then we can continue. So where are we? Yes. You know what is CP and what is CV. So specific heat capacity at constant pressure CP, specific heat capacity at constant volume CV, and the formulas were, so CV will be change in internal energy by change in temperature with the constant volume, and CP will be change in enthalpy divided by change in temperature with the constant pressure. Right. So these formulas can be used to solve problems. Just make a note of it. Then, yes. So what is enthalpy? So enthalpy, H is equal to U plus VV. So using the definition of enthalpy, that is H is equal to U plus VV, and writing the differential of enthalpy, the relationship between the specific heat for ideal gas will be derived. That is Cp plus Cp is equal to Cv plus R. So that can be derived by the use of enthalpy equation. That is enthalpy equation is H is equal to U plus Cv. Then if you want to, if you differentiate this one, we can have dH equal to du plus Pv is equal to RT. Right. So we can have this one. That is RT. If you differentiate this RT, you can get R into dt. So we can have dH du plus R into dt. So this dH can be replaced. Yes. This dH can be replaced as Cp dt. Yes, because Cp is equal to dH by dt. And this du can be replaced as Cp being CV is equal to du dt, du by dt. So we can replace these two terms and we can have our dt. So if in the other terms there is a temperature difference is same, so we can neglect this temperature dt. So we can have a Cp equal to Cv plus R. So from this equation, so we can have R Cp minus Cv, that is ideal gas function will be Cp minus Cv. If you want to find the R, you can use Cp minus Cv. So we can find the unknown values. So if Cp and R given, so we can find the Cv. Cp and Cv given, so we can find R. So if R and Cv given, we can find the Cv. We can use this ideal gas equation relation of specific heat capacity can be used to find the values. Also, we can have a specific heat ratio K, or in other notation we can denote mu. So in the thermodynamic processes we discussed mu. So is equal to mu. So they can call by mu or they can call by K. That is mu is equal to Cp by Cv. So we can have these equations. So Cp is equal to R is equal to Cp minus Cv. Then mu is equal to Cp by C. Just make a note of it. Then we have for ideal gas internal energy, specific internal energy, then specific entropy, then specific heat capacity at constant volume, then specific heat capacity at constant pressure, are the function of temperature alone. So these are the functions of temperature alone. Then we can write the change in internal energy and change in entropy for the ideal gas in the form of delta U is equal to, that is change in internal energy. So final internal energy minus initial internal energy can be calculated as a change in internal energy delta U. Then this equation can be written as U2 will be Cv delta T. So U2, so U is equal to Cv dt. So we can replace this. We can take the so U2 will be Cv dt minus U1 will be Cv dt again. C dt in the sense. So we can take the Cv common. We can take Cv change in temperature. So it is Cv delta T. Also, we can relate the enthalpy as H2 minus H1. So change in the exit enthalpy minus the inlet enthalpy. So also have the equation delta H as Cp d2 minus T1. Just make a note of formulas alone, right? Then with the use of the formulas, just we can try to solve this example. Just go through the example. An ideal gas is contained in a closed assembly with an initial pressure and temperature of 220 kilopascal and 70 degrees Celsius respectively. So we have T1 220 kilopascal and we have T1 70 degrees Celsius, and the system is closed. So we have a constant volume process. Yes. So if the volume of the system is increased, right, before the at state 1, the system is closed. So then at state 2, the volume of the system is increased 1.5 times, and the temperature drops to 15 degree Celsius. So we have V2, V1 is equal to, V2 is equal to 1.5 times of V1. Then drop minus 15 degrees Celsius, that is 220 minus 15 will give you a temperature T2. So what do you want to find? Determine the final pressure of the gas. So we want to find the P2. So just to take states 1 and state 2. So we have at state 1, they gave pressure P1, they gave temperature T1. So just there is a convention with the Kelvin. Just go through this. So P1 220 kilopascal and T1 will be 343 kelvins. Also in state 2 we have only 15 degree. So T2 will be 15 degrees Celsius. So we can convert this into kelvins. So 288 Kelvin. So temperature at state 1 will be higher and temperature at state 2 will be lower. Then we have volume 2, that is 1.5 times of volume 1. So we can use ideal gas law. So PV by T is equal to constant. So we can use P1 V1 by T1 equal to P2 V2 by T2. So just you have to know the formula ideal gas law. It is PV equal to mu RT. So we can neglect the R here. So we can have PV. So for different states, so P1 V1 by T1 is equal to P2 V2 by T2 equal to P3 V3 by T3 equal to P4 V4 by T4. So we can extend the equation for the different states. So here we have only two states. So we can have the equation as P1 V1 by T1 equal to P2 V2 by T2. So the known values were substituted to form the unknown values. So unknown value is at P2 here. So we know the value of V1, we know the value of V2, then we know the value of P1, yes, P1, and we know the value of P2, then we know the value of, that is 220 again. Here is P1, right? Here is P1, right? So if you substitute the values, then we can get the value of unknown value P2 here. P2 here is 123.15 kilopascal. Right, just with the use of ideal pressure at the state 2. So this is a simple example. Just go through the example. So direct values are given, and the unknown values are found from the equation of ideal gas law. So we can move to the next question. So a closed assembly contains 2 kg of air at an initial pressure and temperature of 140 kilopascal and 210 degrees Celsius respectively. So we gave 2 kg of air, that is mass given, and the pressure, initial pressure and temperature is P1 will be 140 kilopascal and T1 will be 210 degrees Celsius. If the volume of the system is doubled and the temperature drops to 37 degrees Celsius, so they gave V2, they gave T2. Determine the final pressure of the air. So air can be modeled as an ideal. Again, so the same problem. So here T1 given, T1 also given. We have to find the state 2, T2, T2 given, V2 also given as a condition. So like in the previous example, so here also we can use the same equation, that is P1 V1 by T1 is equal to P2 V2 by T2. Then the known values are substituted to get the unknown values. Just try to solve from your end. Just try to use the calculator, scientific calculators. Only we can get the practice. Otherwise, you don't know where to enter the values. Just the pressure, these volumes will be in kilopascals and temperature in kelvins. They have to substitute. Then the pressure is in kilopascal, so they introduced into the 3. That is, the pressure want to be substituted in the form of Pascal. Then we can substitute the volume as meter cube. So that's the volume. the unit will be in meter cube. So if you substitute the values, we can found the unknown values T2, and that will be in kilopascal again. So that your answer will comes in Pascal, and you want to convert that Pascal into kilopascal. That is 4.93. Just try to use the calculators and check, cross check these answers by your right. Then only we can get practice. So these two problems will be same. We can move to the next problem. An automobile tire with a volume of 0.6 meter cube is inflated to a gauge pressure of 200 kilopascal. Calculate the mass of air in the tire if the temperature is 20 degrees Celsius. Right. So they gave some data. That is, just read the data carefully. They gave volume 0.6 meter cube of a tire. Then this is inflated to a gauge pressure. Yes, note on this words, gauge pressure. So the pressure should be universal pressure. So the pressure should be universal pressure, but they gave gauge pressure of 200 Pascal. So that if they gave this gauge pressure, you want to convert the pressure. Thus we have to add the atmospheric pressure to the gauge pressure. Then only we can get the original pressure. Right. So this is there is a conversion. There is a conversion. So if gauge pressure given in the problem, just we have to add the gauge pressure to the atmospheric pressure. That is 100 kilopascal approximately. That will be 100 point something. So you can take approximate value of atmospheric pressure. Then we have to add to get the pressure at state. Right. So this 100 comes because we have to convert this gauge pressure into normal pressure. So we have to add the atmospheric pressure to this gauge pressure. So pressure can be 200 plus 100 kilopascal. Then temperature gave. So temperature values given in your problem. So take 20 degrees Celsius, then convert it into Kelvin. So we have to add 273. Then we can get the temperature in Kelvin. PV equal to mRT. So we want to found the mass. What we want to calculate the mass. 6.5. So we want to calculate the mass. So we can use the formula PV is equal to mRT. So P here is just be careful. V here is volume, not specific volume. So we can have the volume. So volume is given. So we can take straight away. So if any specific volume given, so we have to convert. So we have mass. If you have a specific volume, you have to convert this into volume. So we can directly take this equation to found the unknown mass m. Just substitute the values P for values V, value of R. Just remember this universal gas constant R. That is 287 Newton meter per kilogram Kelvin. So this is a constant value. Just try to remember at any time. So like acceleration due to gravity G in the E1. This also a constant value. Just try to keep in mind. This 287 Newton meter per kg Kelvin. That is your universal gas constant, or we can take from the property tables that will be available. Just you have to search. Right. Yes, this way. here kilojoule per kg Kelvin. Right, so there will be a change in units. Just try to remember this. So if you substitute the known values, we can get the unknown value m. Then that will be, if you calculate, you can get 2.14 kg. Just try to cross check these values from your end. Then only we can get the practice. Then we can move to the next step, supplementary problems. Just try to solve as an assignment. So we are forcing you to solve the assignments because we have a lack of times. So just try to solve this problem. Then only we can examine how you are understand about the thermodynamics. Just try to solve these problems. So this will be easy only. So just try to solve this kind of problem. Right. Then we can practice of basic thermodynamics and cycles. So this properties of pure substances, chapter 2 is over here. So just go through this PowerPoint, then you can get much more understanding about the properties of pure substances. So here we can use the refrigerants. We can use water for steam purpose, water and steam, water vapor. Then we can use air as an fuels. So just these properties of these pure substances can be studied by the use of the steam tables. Just to go through this. Then we can move to the next chapter. That is the first law of thermodynamics, energy equation. So already we discussed this slide. So just we can briefly go through these slides. So energy analysis of a closed system was discussed in early classes. So just get a quick go through. So first law is referred as a law of conservation of energy. So the energy neither be created nor destroyed. So this is a closed system. So if you provide a heat supply, or if you the transfer of heat to the system or out of the system, they can work into the system, work by the system or on the system. So the energy equation will be total energy entering the system minus total energy leaving the system will give you the change in total energy of the system. That is E in minus E out will be delta E. So as per first law of thermodynamics, delta U is equal to Q minus W. We can use this thermodynamics for energy also. So we can that is E is equal to internal energy, U is equal to internal energy. So we can replace the energy E system of delta U. Then this E will be the sum of internal energy plus kinetic energy plus potential energy of the system. So we can have delta U plus delta E is equal to delta U plus delta KE plus delta PE. So if you substitute this delta E value to the first law of thermodynamics, we can have Q minus W equal to delta E, delta U plus delta KE plus delta PE. So this is the important for steady flow energy equation. So here we are looking the energy equation alone. So this is the energy equation. So we can use this energy equation for any states and systems. Closed system. So this energy equation for closed system will be look like this. So Q minus W is equal to delta U, because there is no velocity in the closed system, and also there is no elevation. So we can neglect the kinetic energy and potential energy, and we can have the only Q minus W is equal to change in internal energy. Then this first law also can be written in details as Q net, that is specific heat transfer, net heat transfer minus net work done equal to change in internal energy plus change in kinetic energy plus change in potential energy. So unit will be in kilojoule per kilogram. So if the unit in joule per kilogram, just we have to switch. You can open a full slide. Then we can use point option. So we can take 1 point. You can take corrections. So here, so unit in kilojoule per kilogram. So if you want the unit in joule per kilogram, sorry, I'm using mouse, so let us only clear. Just try to understand. Yes, if you want the unit in joule per kilogram, just we have to forget these thousands. Yes, but you have to put the values of internal energy in joules. So here the internal energy values will be in kilojoules. Okay, so if you substitute the internal energy values in kilojoule, we have to use 1000 in the denominator of both the kinetic energy and mechanical and potential energy. If you use the internal energy in joules, just in joules, we have to introduce how can we convert this kilojoule of internal energy into joule? Just by dividing 1000, right? So if you introduce, we can get a kilojoule of internal energy. Then we have to multiply with all of these one, right? So because of that only, so 1000 were multiplied here. So 1000 came here is because of the unit conversion. So if the unit in kilojoule per kg, so we have this equation. So there will be 2000 and 1000 in the denominators of Ke and Te. And we want to substitute the internal energy values in kilojoule alone. Okay, just keep in mind. So if you want the same equation in joule per kg, just we have to forget these thousands in the denominator, and we have to substitute the internal energy values in joules. Okay, just try to understand these equations. We can have two kinds of equations because of the units used here. Yes, do you have any queries? I think the last class someone asked these questions, so I think it was clear now. Just a unit conversion. So if you use this equation straight away, conversion is right. So if you use this equation straight away, so you want to substitute the internal energy values in kilojoule, and the velocity will be in meter cube per kg. Then the G value, then Z value will be in meter. So if you want this equation in joules, just you have to use the value of internal energy in joules. Then we can neglect these thousands. Okay, there was unit convention alone. Just try to understand. Right. So also we can have this first law of thermodynamics in another form. That is here. That is specific heat transfer. That is heat transfer. That is net work done. Also we can have in capital letters. That is because of by mass. So if you divide this specific heat transfer by mass, we can have this capital Q net. If you divide this specific net work, we can have this capital letter W, that is work done, net work done. So this can be taken to the another side. Right? Just here we are just multiplying this M in the LHS and RHS. Then we can get this same equation as capital Q net minus W net equal to M into internal energy plus change in kinetic energy plus change in potential energy. Right. So this is the energy equation. So just try. This is the term energy equation. So in the subsequent classes, the terms will be in steady state energy equation, steady flow energy equation. So here there is no flow, but the energy equation will be look like this. So energy equation, Q will be there, W will be there, U internal energy will be there, then velocity. This is not volume. Here V denotes velocity. You know, for kinetic energy, we have to use the velocity. So the capital V also will be used for denoting volume, but here capital V denoted for velocity. So there is an error. That is here is V2 minus V2 square minus V1 square, and G into Z2 minus Z1. That is changing kinetic energy and changing potential energy. Right. So this is energy equation. We can use this energy equation for constant volume process. As you know, for constant volume process, we don't have work done. We don't expect the work done by the constant volume process. So we can neglect this constant volume process W. That is unit is equal to mass into change in internal energy plus change in kinetic energy plus change in potential energy. That is there is a change. There is a error. That is by the error in the PPT. Just note down the change in kinetic energy of V2 square minus V1 square, and your change in potential energy will be G into Z2 minus Z1. Right. Just make a correction in this. This I will correct. Z2 and Z1. Here V2, here V1. Also same V2 square minus V1 square by 2. Here Z2 G into Z2 minus Z1 by 2. So this is the energy equation for a constant volume process. The energy equation for constant pressure process can be written as, so as we have the energy equation here. We have the energy equation here. One process in constant pressure process. So the W net will be, so W can't equal for constant pressure process. W is equal to P delta V. So this W is equal to V delta V, that is P V2 minus V1 can be replaced for W in the energy equation to get this equation. So we can have a Q net minus P into V2 minus V1 equal to M into change in internal energy plus change in kinetic energy plus change in potential energy. Then we can bring this P delta V into the RHS. Then we can have this U2 minus V1, that is change in internal energy, plus P2, the P into V2 minus V1. Right. You know the entropy equation in the last slide, H is equal to U plus PV. So U plus PV. So this U2 plus PV2 can be written as H2. Then this U1 plus PV1 can be written as H1.
Sir,
Yes, ma'am.
sir, I have a doubt, sir.
Yes. Yes, you can ask.
Sir, how can we include the left hand side P into V2 minus V1 into in a common bracket with M, sir?
Yes. Yes. We
Why are
keep
we including P in common with M, sir? Shouldn't we write with separately, sir?
here P into, say, H is equal to P U plus P into small v alone. Right. Just here H is equal to U into U plus P into small v, that is specific volume. But here we have only we have volume. So specific volume, we have to divide the volume, the capital V by M. So we can
Okay, sir.
so this M will be cancelled. Right.
Okay, sir.
Yes.
Okay, sir.
Right. So we can have the energy equation for will be Q net is equal to M into H2 minus H1. That is change in entropy plus change in internal energy, kinetic energy plus change in potential energy. So just keep this energy equation in your mind. In addition, we can reorder the equation, energy equation. So for constant pressure process and constant volume process, look like this because of we don't have work done on the constant volume process. For constant pressure process, we don't have we have work, but in the form of enthalpy. So we can rewrite the equation as H2 minus H1. That is energy. Changing internal energy can be replaced by changing enthalpy. In mind, enthalpy equation will be H is equal to V into P, pressure, into small v, specific volume. Then this is the schematic of closed system. So this system is closed. So we can have the mixture, that is heat vapor mixture into the system. If you keep on adding the heat energy to the system, we can't expect the work as an output. But in this system, piston slide arrangement, if you add heat energy Q into the system, we can expect work. If you do work done on the system, we can expect heat releasing from the system. So you know much more about the system. So we no need to go on that. We can move to the problems. Just try to solve this problem. So this will be based on the energy equations. Right. Just read the questions 2 times. A closed system of mass 2 kg undergoes an adiabatic process. The work done on the system is 30 kilojoule. The velocity of the system changes from 3 meters per second to 15 meters per second. During the process, elevation of the system increases 45 meters. Determine the change in internal energy. Here, they gave a closed system, right? So we have a constant volume system. Mass M given 2 kg undergoes an adiabatic process, right? So just this is an adiabatic process. You know what is adiabatic process? a quick process. Then the work done on the system is 30 kilojoule. So they gave W on the system, just note on the word on the. Then the velocity of the system changes from 3 meters per second to 15 meters per second. So we have V1 3 meters per second, we have V2 15 meters per second. Also they gave delta Z. They gave elevation, difference in elevation, that is the delta Z. So Z2 minus Z1 will be 45 meters. So we can use the energy balance equation, that is energy equation as Q net minus W net is equal to M into change in internal energy plus change in potential energy, plus change in potential energy, V2 square minus V1 square, G into Z2 minus Z1. Right. So we can use the equation, the known values that we substitute. So here there is no heat flow. Well, the remaining equations, we have the value for W net, that is minus right. So right, we want to count this one around. Yes, change in internal energy. Into internal energy, mass into kinetic energy, mass into potential energy. It's 2 into delta U plus 2 into KE plus 2 into P. So we know the values for V2, 15 meter per second. We know the values for V1, 3 meter per second. Then we know the values for elevation, that is 45 meters. So that should be multiplied with the G. So you know the G value is constant. Acceleration due to gravity G 9.81. So if you substitute the values, so just remember this the equation in the denominator is 1000. So we will get the internal energy in kilojoules. If you don't have this, the internal energy got from this equation will be in joules. Right. So also we have to use this work done in joules to get the change in internal energy in joules. Right. Just to be clear on the units also. So you can have the change in internal energy as 14.451 kilojoule or 14,451 joules. Can you able to hear me?
Yes, sir.
Yes, sir.
Yes, connected. Can you able to hear me?
Yes, sir.
So there is some a network issue. So we disconnected. Now I think we connected again, so we can continue. So we are discussing these problems. So we have the values. Based on the values, we can use the energy equation. Here is the constant value process. So the known values were substituted and the unknown value delta U were found by use of the equation. Then we can move to the next problem. Let's try to solve this problem. Take just try to read the problems. Take 2 minutes time. Yes. Yes. Just try to solve the problem, ma.
Sir, slide is not visible.
Sorry, come again. I didn't get you.
Sir, slide is not visible.
That is not visible. For others, what about for others? Wait, I will reopen. Stop sharing. Escape. Then again go to things. Then share. Open. Share. Share. Yes. Can you able to see the slide now?
No, sir.
What about for others?
It's visible, sir.
Yes, fine.
Yes, sir.
Yes, fine. Just try to solve this problem. Steam at 1000 kilopascal and 92 percentage, 9%. Yes. That some disturbances. Right. So we have P and we have X. Are you connected? Yes. Fine. Just try to solve this question. Students, are you there?
Yes, sir.
Yes, fine. கொஞ்சம் பேசுங்க, எதுவுமே கேட்க மாட்டேங்குது. இருக்கீங்களா தெரிய மாட்டேங்குது. Right. So we are solving this problem. So we have they gave P1, they gave X, and is heated in a rigid container that is constant volume process until a pressure is 2000 kilopascal. P2 given for a mass of 0.05 kg m given. Calculate the amount of heat supply. That is, we want to find the heat supply Qn. The total entropy change. That is for entropy change. That is delta H. So we can try to solve the problem. So we have P1 and we have X1 So with the use of steam table, we can so here we denoted yes. So they have denoted steam. So we can use steam tables to find the other properties. So we know how to use the steam tables. So at pressure P 1100 kilopascal, we have to look the specific volumes. So we can so we can go to the steam tables. So here I was using the property tables was added newly in your files folder. So we have to look at the properties of steam. So where is that? Yes, that water temperature. Yes. So we have to look at this table 4, T4. You can go back. Yes, I think this G2, G3, that's A4 here. So for 1100 kilopascal, so 1100 kilopascal. So here the students, are you there? Lots of disturbances.
Yes, sir.
Yes, sorry for the disturbances. It's like there is some error. So just are you connected?
Yes, sir.
Yes. Right. So you have to find the can you able to hear me now?
Yes, sir.
Yes, sir.
Yes, there is something.
Yes, sir.
There is some network issue. So I get reconnected. So where are we? So we have to solve the problem. Yes. So to solve this problem, we have to use the steam tables. So in the steam table, the subsequent P1 value can be taken. There was P1 values here in 1100 Pascal, 1100 kilopascal. So the values in pressure here is in kilopascal. So directly we can 1000, 1100. So you have to use the interpolation. Discuss பண்ணலாம். ஜெரமன்
சார்
எதுனா இஷ்யூ உங்களுக்கு ஃபேஸ் ஆகுதாமா?
சார் வாய்ஸ் பிரேக் ஆகுது சார்.
வாய்ஸ் பிரேக் ஆகல. நான் பேசிட்டு தான் இருக்கேன், கண்டினியூஸா பேசிட்டு தான் இருக்கேன். பட் ஆனா உங்களுக்கு வந்து ரீச் ஆக மாட்டேங்குது. ஸோ இங்க வந்து இது ஒரு எரர் காட்டுது, நெட்வொர்க் கீப் ஆன் கனெக்டிங் அப்படின்னு சொல்லிட்டு எரர் காட்டுது.
நெட்வொர்க் ப்ராப்ளம் இருக்கு சார்.
இங்கேயே இருக்குன்னு நினைக்கிறேன், எனக்கே இருக்குன்னு நினைக்கிறேன்.
உங்களுக்கு சார்
கேலப்ல சிஸ்டம் தான் யூஸ் பண்ணிட்டு இருக்கேன். சரி, ஓகே. சப்போஸ் நீங்க கனெக்ட் ஆகல அப்படின்னாக்க அகைன் கனெக்ட் ஆனதுக்கு அப்புறம் ஒரு இன்டிமேஷன் கொடுங்க. ஜெரம் நீங்க கிளாஸ் ஸ்டார்ட்.
எஸ் சார்.
சப்போஸ் வெளியில போயிட்டு டிஸ்கனெக்ட் ஆகிட்டு அகைன் கனெக்ட் ஆச்சு அப்படின்னாக்க ஜஸ்ட் வி ஆர் கனெக்டட்னு சொல்லிட்டு ஒரு இன்டிமேஷன் மட்டும் கொடுங்க.
ஓகே சார்.
கனெக்ட்ல இருக்கீங்களா இல்லையான்னு போயிட்டு உங்களுக்கு தெரியும் டிஸ்கனெக்ட் ஆயிடுச்சு அப்படின்னு சொல்லிட்டு. அப்போ டிஸ்கனெக்ட் ஆகிட்டு கனெக்ட் ஆச்சு அப்படின்னாக்க ஜஸ்ட் இன்டிமேஷன்.
ஓகே சார்.
ஓகே, ஃபைன். We have to solve. We can have a pressure 1100 kilopascal. Then we can use this steam table. So this value. So we have 1000 pressure and we have 1123 pressure. So we have to use the interpolation to found 1100 kilopascal. So if you interpolate, the value will be in between these. So VF will be in between these 0.001130 approximately. Then VG value will be in between these two. So 0.7, 0.175 something, right? So we can check. Yes, the value taken here is around S 0.01113, and so they taken this value 0.17. Yes, 0.17. Right, so we have to use the steam table. We have to use the steam table. Let's call it. Just wait a minute. VFG values. So VFG values won't be in the table, so we can take VF value and VG values. So VG value minus VF value, we can get VFG values. Then we know what is X quality. We give the quality value X. So we can found the specific volume V1 and state 1. So specific volume will be 0.1634 meter cube per kg. So like that, we can found the specific internal energy That is so the specific internal energy also can be taken from the table. So internal energy will be here. So if you interpolate, you can get the exact values of this UF and UFG is approximately 780.1806. So in the table 780.10. If you interpolate, you can get the exact value of this one. So the UF value will be 780.09 and the UFG value will be in 1806.3. So these were discussed in the earlier last class. So just try to interpolate and try to find the value of U1, that is specific internal energy. So also from the table we can found the specific entropy. So we can take the SF value, G values in the same table. Then we can found the value of S1, specific entropy. So we want to found the heat supply and the total entropy change. So we have to go with the state 2. For a rigid container, there won't be a volume change. So V2 will be equal to V1. We can take this V1 values, specific volume. So we have to so the value will be in between these two. So that will be approximately 0.01175 something. Problem. Ramanan connect ஆயிடுச்சாமா?
Yes, sir. Yes, sir.
Yes, okay. So if you compare the specific volume value, so that will be 0.163 will be greater than VG. So if you use this steam table, the VG value will be 0.1 alone. But we have the V value plus 0.16. So definitely V2 is greater than VG. So this is a condition 3. So if condition 3 occurs, we have to use the superheated table. So go to the superheated table at pressure 2000. So this is saturated water. Yes, superheated water. So at 2000 kilopascal. Yes, the pressure in megapascal here, so 2002 megapascal. Right, come again. At superheat, find 1634. Yes, 1634. So that value will be here. This is energy. What's wrong? Okay, so if you use this superheated table, you can found the values of U2, S2, and H2. Right. So we have the values. So if you interpolate, yes. So here they use interpolation formula, that is U2 minus U1 divided by U3 minus U1 equal to V2 minus V1 divided by divided by U3 minus U1. So if you interpolate, we can get the value of U2, and if you interpolate, we can use the we can get the value of S2. Then if you interpolate, we can get the we don't want the shape here, so we can neglect that. So the question is the amount of heat supplied Q, that is from the energy equation. Q is equal to M into change in internal energy plus change in kinetic energy plus change in potential energy. So there is no kinetic energy and potential energy here, and for a constant volume production, there is no. Then we can have this Q is equal to M into change in internal energy. So we found the U2 minus U1. We have the values. Then we can substitute on the amount of heat supplied. So here the values of Q in plus. So heat is applied to the system. That is 29.43 kilojoule. Also, we want to find the change in entropy. That is S2 minus S1. So we found the value. If you substitute, we can get the value of S, delta S, that is change in entropy. So the question will be like this: just try to get the given value and try to use the formula to find the unknown values. Right. So A rigid tank is divided into two equal parts. Students, are you there?
Yes, sir.
Jeraman, are you there?
Yes, sir.
Lots of disturbance, ma. To conduct. Right. So we can try to solve this question. Okay. So just look at the problem. So we have a pressure at state 1, and they gave the temperature at state 1. Also the other values, and the other on the side is evacuated. The partition is then removed, and this water expand in the water is allowed to exchange. Yes, I think it connected. So we have to determine the volume of the tank, the final pressure, the heat transfer for this process. So, given values. So just wait a minute, ma. ஹலோ இப்ப கரெக்டா இருக்கு. ஜெரமன் கேக்குதா அப்போ?
கேக்குது சார்.
நீங்க இருக்காங்க சார், தனியாவே இருக்காங்க. எனக்கு இருக்காங்க. Yes, we can continue. So to solve this problem, we have P1, we have T1. So at pressure 200 kilopascal and temperature 25 degrees Celsius, we have to look the steam table. So pressure and அந்த சவுண்ட் வந்து தண்ணி வந்து ஒரு டைம் வந்து போகுது, ரெண்டு டைம் வந்துட்டே இருக்காது. பதினஞ்சு மணிக்கு உங்களுக்கு தண்ணி வந்து ஆப்ல போக முடியும். Hello.
Sir.
சரிம்மா 10 ஆயிடுச்சு 10 ஆயிடுச்சு.
Okay, sir.
எது வரைக்கும் கவனிச்சீங்க? எந்த ப்ராப்ளம் வரைக்கும் கவனிச்சீங்க? ஓப்பன் ஐட்ஸ் ஓப்பன் தெரியுதாம்மா? Able to see the PowerPoint presentation. Let's look at this example 3.3. Yes, you can easily understand. So we have to compare. So if temperature and pressure 1 will be less than T saturation. So this condition can be this condition was explained in the last class. So the state, the system is in compressed state. There is subcooled liquid is used. So we have to take right. So we can stop. We can discuss. Then just try to solve these problems also. So the subsequent problems. So 1, 2, 3, 4, 5. So take these also as an assignment. So we can stop here. So we have a time for 1 week. Just try to solve the problems in your home. Then try to send these problems. So that's enough. So we can leave.
Thank you, sir.
Thank you.
Yes, if you have any questions, you can wait and ask. I will be available. Comments.
Sir. Excuse me, sir.
Yes, ma. Yes, tell me.
சார் லாஸ்ட் கிளாஸ்ல ஒரு 2.4 ஒரு சம்மர் இருக்குல்ல சார், அதுல எப்படி டேபிள் பார்க்கணும்னு தெரியல, சொல்றீங்களா ஒரு வாட்டி?
எல்லா சம்முக்குமே டேபிள் வந்து எப்படி பாப்பீங்க ஒரே மாதிரி தான் இருக்கும். 2.4
2.4 அது 0 டிகிரி செல்சியஸ் இருக்கு சார், அதனால கன்ஃபியூஸ் ஆகுது கொஞ்சம், அது மட்டும் சொல்றீங்களா?
Wait, I will open. Teamsல chapter open screen share.
பியூர் சப்ஸ்டன்ஸ் லாஸ்ட் கிளாஸோட இதுதான் சார்.
I will open this question.
ஓகே சார், ஓகே சார்.
These are pure substances. என்ன கொஸ்டின்மா?
2.4.
This question, yeah.
This sum. Yes, sir. This sum.
Yes. Determine the internal energy of the refrigerant 134A at temperature 0 degrees Celsius and the quality 60%. We have to use the refrigerant 134A table. So that was not given in the last class. So now that was added in today. We can
Okay, sir,
you
okay.
can refer this.
Sir, so we should not see the values in table A5, no, sir. Excuse me, sir.
So if you go to these files, there will be property tables and chart will be available. Can you able to see this table?
No, sir. Only PPT is there on the screen, sir.
This now.
No, sir.
Now,
No,
property
sir.
property table.
PPT. No, sir.
In which download. So in your files folder, there will be a PDF file, property tables and charts. What is in today's class we use?
Yes, sir. Yes, sir.
Someone is meeting me. Okay. Sarjana? Saujanya, are you there?
Sir.
So just you have to use this table mark. Which
Sir, we have to use table A5 or refrigerant table, sir.
just go to this. So if you look at that property tables and chart, the refrigerant R134A table will be in table 11, A11.
Okay, sir. Okay, sir. I saw the values from table A5, sir. So I got confused, sir.
No, just you can refer the index. So, but
Okay.
the table A5 was used by the author of that slide. So we are using this table property and this table. So we have to refer this table. So just just we have to look at table A11 here. A11.
Okay.
If that
Okay.
if that is supergated, we have to use table A13. So just refer table A11, A12, and A13 for refrigerant 134A.
Okay, sir.
Okay, that's fine. Yeah, fine.
Thank you, sir. Thank you, sir.
Okay.
Sir, sir,
Yes. Can you able to hear?
yes sir.
Yes, tell me.
Sir, examக்கு இந்த tables எல்லாம் கொடுப்பாங்களா sir?
Yes, கொடுப்பாங்க. They will provide.
Okay sir. Thank you sir.
Yeah. Okay, fine. Then any other queries? No queries. Yes.
எக்ஸாம்ஸ்க்கு வந்து இந்த மாதிரி ப்ராப்ளம் மாதிரி வருமா இல்லை தியரி கொஸ்டின்ஸா வருமா சார்?
Full and full problem will be asked. ஆமா, ஃபுல்லா ப்ராப்ளம்ஸா இருக்கும். ஜஸ்ட் பேசிக்ஸ்ல கொஞ்சம் தியரி கேட்கலாம். நம்ம கிளாஸ்ல டிஸ்கஸ் பண்ற ப்ராப்ளம் தான் கேட்பாங்க. ஜஸ்ட் யூ டோன்ட் வரி. ஓகேமா. Means 15, 16. சரி, இந்த வர சொன்னீங்க. இந்த முடியல சொன்னீங்க. ஆமா சொன்னீங்க. ஒண்ணே ஒண்ணு இந்த ஃபைல்ஸ்